chapter 5 actually, the first section's composite functions, but the chapter actually is exponentials and logs, which I like. It's different. Anybody remember anything about your exponentials and your logs? You don't like them. Thank you. Why big thumbs down?
Oh, no, I just don't know anything.
Was it exponential like multiplying?
It's multiplying. Kinda. You just don't remember. So it's not that you don't like them, you just don't remember it. You remember kind of doing it, but it's gone.
Yeah. All
Okay.
I remember about logs is like the only like equation I know is like you put a number under it and then from there like that number gets put up somewhere else.
Oh,
Use
these?
that.
Yeah.
So, where
No. Those aren't it. Those are your functions. Yeah, and actually the reason that they do logs and exponentials at the same time or in the same unit is because it's the same problem. It's two different ways to write something. So it's almost like saying if you wanted to count to 10, you could count in English or you could count in Spanish. But the bottom line is you're still just counting a number, and exponentials and logs are the same thing. It's a different way of writing. A log is just a different way to write the exponent. And so it boils down to which one's easier to solve. So if it's easier for you to solve exponentials, you throw your logs into an exponential. You like doing logs, you throw your exponential into a log. It just makes it easier to work with. Two different forms to do the same problem. All right, but before we get there, we're going to do composite functions. So, first question is, what is composite mean? Who's my English lovers? What's composite mean? You're all a bunch of big thumbs down today, man. Everything I ask. Yep, that's exactly it. A composite means made up of various parts or elements. Okay, so a composite function is a function made up by two or more functions. Okay? And so the way you write it, there are two ways. You can use the open dot circle, and that's read F composed with G, or you can kind of nestle them. And then if they're nestled, so like the F of G of X, the G of X is your inside function, and then the F is the outside function. And when you're working with them, you always start on the inside. Just like grouping and parentheses and so all that good stuff. And work your way out. Okay, good so far? Alrighty, then, different ways you can have your function. You can have it shown as a graph. Okay, you can have it as a table. You can have it as a function. Alright, so if we're looking for the H comprised of F of 2, what you want to look at first, that's like saying the H of F of 2. So we're going to look at what F of 2 is. Well, F of 2 is like, what, about -9? So then that means that I would look for the H of -9. which means I'm going to have negative 9 squared minus 1. Because I put my negative 9 in for, oops, can't see the, in for x. Is everybody with me on that? Okay, so I found the f of 2. Are you all with me on that?
Yeah.
Okay, so since I found the inside, now I put that answer and put it in the outside function. My outside function is the h function. F of 2 is negative 9, so I put negative 9 in. That's about as far so you can still see. Okay? All right, so,
Negative 9.
huh?
How'd you get negative 9?
Because I was looking for the f of 2. My function, or f function, is the graph. So when I look at where my 2 is, my y is going to be a negative 9.
Okay.
Because it's this point and I kind of rough guessed it over. Awesome. All right, so h of negative 9 is going to be the square root of 81 minus 1, which is going to give me the square root of 80. Good. Okay, so start with your inside first. The g of negative 1 gives me 2. So the g of negative 1 is equal to 2. And now I want the h, so that makes the h of 2, because I'm going to put that in for there, the square root of 2 squared minus 1. So h composed with g of negative 1 is going to give me the square root of 3. Because square root of 4 minus 3 gives me, or 1, gives me 3. Good? Is this coming back to you? Algebra 1 and Algebra 2. Okay, it'll come back. Bear with me. It'll be back. Okay, so let's evaluate the f composed of g of 4. Okay, so that's like saying I'm going to do the f of g of 4. Okay? So that means that my first that I'm going to do is evaluate the g of 4. Okay? So my g of 4 is going to be 3 minus 1/2 of 4 squared. So 3 minus 1/2 of 16. And so the g of 4 is going to give me negative 5. Okay. Now, second step is that then I'm going to put this, I put the answer in, so now I'm looking for the f a negative 5. Everybody with me on that? So now I put in 4 times negative 5 squared minus 3. So 4 times 25 minus 3. And that gives me 97. So the f composed with g of 4 is going to give me an answer of 97. You want to do another example with that one? With that kind? One more? You want to do G composed of F of 2 or F of composed of F of 1?
F composed of F1.
All right. F composed of F of 1 means I'm doing the F of 1. So my F of 1 is going to be 4 times 1 squared minus 3. Good? All right, so that's going to give me 4 minus 3. And so the F of 1 is going to give me 1. Now, I'm looking for the F of 1. That answer is, so now I'm looking at the F of 1. Well, we just found that one, didn't we? That's, we already know is 1. So that means that we can say, hey, well then, the F of 1 is going to be 1. Hmm?
I chose.
Okay. All right. Now, who's got a calculator can borrow real quick? 84. Anybody right there? Because on the next page, I'm going to show. It's here. The directions are here, but I'm going to show you how. If you're evaluating for a specific number, you can put it in your calculator and it will calculate for a specific number, okay? So, I basically f of x is the same as a y equals, right? So I'm going to enter in f of x for y1. So I have 4x squared minus 3. And then I'm going to make g of x y2, so 3 minus 1/2 x squared. All right, everybody with me on that? Okay, so this is like y1, that one's my y2. All right. At your home screen, you leave those plugged in. At your home screen, remember how we did our alpha trace? And we get to get our alpha zoom to get our matrix? There's all these little things on the bottom. If you go over, it'll let you select those y1s, y2s. All right? So I can just say, hey, if I want the f of g of 4, that's like saying y1, y2 of 4. Okay, so I'm going to pick y1, and I'm going to say I need y2 of 4. And I don't have a parenthesis in there somewhere. Oops. All right, trace y1 of y2 four. I think maybe that's it.
Are you supposed to have that one after the y2? Those parentheses.
We just did this a minute ago. Alpha 2. Why is it not working now? That's so weird. I got a parentheses in here somewhere wrong.
Don't have like a close one. I guess like y1 and then goes to y2. And then you do like the other, not like to close it, but
The open.
the open one. So where you just put the 4, put like the open things. Not to close the Y2. Yes. I think that's what you're
Isn't that what I did before?
No,
Yeah.
we're closing the Y2 and then.
Oh, there you go. All right, sorry, my bad. I was thinking I was hitting the right one. Anyway, and that'll give you the exact same number.
So we pretty much just double check.
Yeah, yeah. And honestly, for me on those, as long as you know how to tell which is your Y1 and which is your Y2, that's gonna be the same thing. All right. So let's make some composites functions. So when we have the F composed with G, now we're not evaluating for a specific number. We're just finding the ending composite function. All right? So what you're going to do is that's like saying the F of G of X. So this is your inside function. You're going to put your inside function in for X. In for the X of the outside function. Okay, so F of X is 2x plus 3. So 2, and I'm going to replace my X with my G. And then I simplify. To 6x plus 6. Does that make sense?
Why is it plus 6?
Because I got to distribute. Okay. If I'm doing G composed of F, that's like saying G of the F of X. So this time I'm using my GX and replacing the X with my F of X. Does that make sense? All right, so that makes the G of F 6x plus 9. Are these ringing bells from last year?
Yes, I know that good though.
Okay. Are we good with those? All right, here's the new one then. Okay. Now, what we're doing, if we have rationals, is the exact same thing. We just got to get rid of those fractions that we don't want in the denominator. So, if I'm doing the F composed of G, that's like saying the F of G of X. So, I'm going to take my F of X. All right. And I'm going to replace every X with my G of X. Okay, so I'm going to make that a G of X. Does that make sense? So, that means I would have X plus 2 over X minus 3 minus 5. And then X plus 2 over X minus 3 plus 1.
That says fall.
Yeah. You can say that instead of F composed of G. Let's just fog it. Okay? Are we good on that so far? Okay? Now, we can't have fractions in a denominator, so we gotta get rid of those. What's the next step to do that? What do you do? How do you do to get rid of fractions? Multiply the bottom by the top.
Or
Multiply the bottom.
yeah,
Multiply the bottom. So does that mean I'm gonna and I got to do it to the whole thing because then it's like multiplying by 1. So do I do, so there's my fraction from the bottom, right?
What about the plus one?
Well, that's just a whole number. That's like a, but how, when I multiply those, is that, what do I do next? Because is that going to clear out from fractions?
Change the sign.
No. Don't give up. Think it all the way through.
Reciprocal of it.
No, but that's a really good thought. What do you think? We don't want fractions in the denominator, right? If I'm just looking at the top part, what would I do to clear that fraction?
Oh, to the top fraction, right?
Yeah, if don't even think about the bottom fraction, I'm only thinking about the top. What would I multiply by?
Was I X minus 3?
Just the x minus 3. That's exactly it. Okay? So when you're multiplying, you're right, but you said multiply by the fraction. You're only multiplying by the denominator of the fraction. Okay? So
Man, I wish I had played out.
And that's the whole, not the whole fraction in denominator. Okay? So, because now, if I come over here and look, and remember this, the whole is a whole thing, so I have to distribute to both. So, I'm left with x plus 2 minus 5 times x minus 3 on the top. Is everybody with me how I got there? And then when I multiply, I'm going to be on the bottom left with x plus 2 plus x minus 3. Good with that one? Okay, so now I keep distributing and I get the x plus 2 minus 5x plus 15 over, I can combine, so 2x minus 1. So, my f composed of g, I made my little circle a little bit smaller so it doesn't look quite so fog, is going to be negative 4x plus 17 over 2x minus 1.
Is that it? Oh, yeah.
And that there's nothing else because remember, these are one number in one term, so you can't simplify them down anymore. Okay? So that's just your answer right there. Okay? Good?